This is 152, instant response, and we're down here. We're going to talk about investigating Windows systems, and next week there'll be another of those guest lectures, which have been very good. This one is, I think, on cybersecurity. Oh, I'm up here. Yeah, 11. Next one will be one of those on cybersecurity. So they won't have a normal lecture. We'll just have a Zoom link for the Bay ICT talk, and I'll be around to answer questions after that. Anyway, so let's take a look at investigation, analysis methodology. All right. So here's the basic process. First, you have to decide your objectives, then gather some data, inspect it, which will probably involve converting it, normalizing it, and so on, then perform some analysis and evaluate the results. Although this is, in fact, an iterative process, you keep finding more and more data and analyzing it. So defining your objectives is a big deal. Your non-technical managers will usually not understand what is possible and reasonable, and you have to guide them. So you're going to have to decide what, from a commanding knowledge of both the situation and the technology, understanding what is reasonable, what you can possibly find out, and how long it would take. We mentioned quite a lot before about how there are a lot of investigative procedures like take complete images of hard drives and servers is not really helpful because that takes too long and it's too much work, and it's much more efficient to do a targeted live capture in most cases. Yeah?
Are you able to project the slides?
Oh, it's not projecting. Why, thank you for telling me. That's no good. I'm amazed. Before, I can't even see it unless it's projecting. Why, thank you. Something has changed. Oh. Let's see if it comes on. There was a power outage and a lot of strange noises. Perhaps something broke. More likely it just needs to warm up. Looks like something's happening. I'm glad you told me.
Mm-hmm.
Before, I couldn't even see it on the screen unless it was going there. But after the power outage, I think it got sort of put in a strange mode. But this looks like it's going to come up. Ah, good. Thank you. Yeah. All right. So, I got to go here. All right. So you decide what resources you need, who's interested in it, and what do people plan to do with your results. This is the hard part for me. I was just explaining this to one of my consulting partners this morning. I have a hard time communicating with non-technical people. They think in a strange way. For example, if you put up a page that contains any numbers or code, they just zone out and don't hear anything you say for a while. It like shocks them. And I'm not any good at understanding how normal people think and communicating with normal people. I can only communicate with tech people. Anyway, so you got to have a leader. So the investigative team has to know who is in charge, and that would therefore keep you on the right track and prevent people just wandering off and getting lost, going down different paths. And you cannot ever prove anything negative, of course. You cannot prove a server is not compromised, even in a logical sense. Mobo has there's a whole category of they say I communicate with non-technical people. I know I don't. Especially business manager types. I can never communicate with them at all. They ask me a question, I always give them the wrong answer, and it's next week when I realize where their mind is at. They think in a whole different way. And I cannot understand what's in their mind, so I give them a useless answer. Like, for example, they never want a straight answer to a technical question. That is seen as harsh and abusive. It's politics. You have to pass them on to politicians who will gently suggest things and not ever make a firm statement that might offend anybody. My father was the same, actually. I've just turned into my father like everybody does. Anyway, it's the same thing Dilbert does in the comics. Why he always offends his dates and stuff. He speaks in a technical term like an engineer and does not have the gentleness and empathy required for non-technical people. I don't understand what they're thinking. When they ask a question, I don't understand it correctly. You have to somehow think the way they do. And I have a friend who can do that, but I can't. So I try to avoid talking to managers. I have this other person talk to them. Anyway, so don't try to prove it impossible, like a server was not compromised. That's essentially impossible. You don't have trails going all the way back. Your logs aren't perfect, and so on. You have to have more well-defined things that you can prove. Like you can look for an indicator of compromise and say whether it's there or not. which does not mean that it's necessarily clean. And this, for example, is something related to that communication thing that I was talking about. Managers will say, okay, what do I need to do to be safe? Okay, so it's clean. Well, now we're secure. I'm going to tell the customer the product is secure. And as a technical person, I would complain about all of that. I'd say, no, our product is not completely secure. That's impossible. I do not know this thing is clean. That's impossible. You cannot say, I cannot tell you what you can do to be safe, which is why, Kevin Mitnick had advice for normal people. How do I protect themselves? This is a common thing. People in the audience, how do you protect yourself? And I'm like, I really have no idea how normal people should protect themselves. A password manager is about all I know. I mean, almost everything I study is not something a normal person can do anything about, like a buffer overflow exploit or something. Just put on the patches when they come out. But they want something else. They want something to make them less afraid. They need sort of like counseling. And they do not want technical information. Anyway, you have to learn to speak their language. And the way they talk is the opposite of the way technical people talk. And here's this point here. You can state an opinion, however, that the system was likely not compromised. And as an expert witness, you can say that. But of course, you can never know for sure that something is not compromised. So you can say, is malware present on this computer? And of course, you can never know. There is malware that is really sneaky, like rootkits, like well-made rootkits. All you can say is that I didn't find any malware on that computer and I ran the standard tools. So if there is, it would be a new form of malware, like a 0-day, which I couldn't detect, or something advanced, which I couldn't detect. And, if you were to say a thing like that in court, you wouldn't accomplish your goal. That's why you have to say things carefully. But here's something you say, is there a particular file on that machine? That you can answer. So you have a scope. If they say, look at this hard drive, look at all the email, that's not good enough. You need to have a more clear definition of what you're doing, like review the files for emails received by this one person within the last month. Now that's something you can reasonably do. So you ask why, you keep asking. So if people say, I need to know this, you say, well, why? I need this, why? This will help you guide to find out what they really want. They will tell you, for example, how much should this server be up? Well, it should be up 100% of the time. And you say, no, that's not an option. And so you have to find out what they really need. And you will probably help them define their objectives. What they really want is to be told, we're completely safe now, we'll never get hacked again, and we've completely removed all the bad guys, so we're safe, they're totally gone. And you have to guide them to a more achievable goal. All right, so you have to know the data. So data on desktop and laptop computers have hard drives, SSDs, external things like thumb drives, and there are virtual desktops, very common these days, where your desktop is on Azure, all the data is on Azure, so it doesn't matter if your local machine is insecure. It matters less anyway. That's an increasingly common solution for work-from-home people. And then you got servers. You got data centers, if you own your own servers, in a server room or communication closet, mounted in racks with probably a whole bunch of servers and drives, and probably clusters of drives in RAIDs or NAS or SANS arrays. Or you're just putting it in the cloud, Azure or something, and then you don't have any direct contact with the hardware at all. And then, of course, your mobile devices, mostly phones these days, but all the iPads and all these devices people carrying, cameras, flash memory, and all that jazz, that's all got data on it too. And so you got storage solutions all over the place, USB hard drives, CDs, DVDs, storage, network attached storages, and those contain data as well. And your network devices, firewalls, switches, and routers. Now these typically do not store user data, and they typically do not have malware on them, although there is malware you can put on them. That was one of the leaks from the shadow brokers, was the NSA's malware to compromise firewalls and routers. So those things are out there, powerful exploits to attack them, and just in the last month, 2 major vendors have had it exposed to authentication bypasses for Palo Alto and Fortinet. So you can log in as administrator without administrator credentials, so you can put malware on them, and it does happen. It's just not the most common thing. But there's almost never user data on them. See, Palo Alto devices will store user data really on the network. They're proud of it. I did not know this. Do they store it to like speed up caches or something? Why would you put user data on the firewall? Anyway, Glow says they're doing that. That's news to me. I'd like to see a Lake article about it. But I'm not doubting you. I imagine it's true. I just was not aware of it. So anyway, then you got, of course, these cloud services, Dropbox, Google Drive, People use all sorts of cloud services, Office 365, and then Azure, Google Cloud, Amazon Cloud. There's tons of services out there, and that's all your data out there. You learned when you were interning. Yeah, that's good. Anyway, so then you have backups of all these devices. You got the iCloud backups of your phone, and you got other backups for almost everything, usually on tape, just because tape is the cheapest way to store a lot of data, but it could be on removable hard drives or cloud-based backups like Carbonite or Mozy, and that's another place where all your data is. So there's 4 types of evidence. There's the operating system itself, which is usually not very interesting. Then there's applications, user data, and network data. So the operating system is going to, the only interesting thing here is not usually so much the operating system itself, but the information about running processes and open network ports and operating system logs. So that's stuff the operating system creates, and that's very interesting, like the Windows registry, and we're going to spend the next 3 classes going through Windows data in detail. And Windows, it's mostly in the registry. In Unix, it's syslog, and in Apple, it's plist files. These are the records kept within the operating system of what someone has been doing, and that is quite valuable. The file systems matter a lot. All modern storage devices have allocation units, so you have a block size, typically 4 kilobytes, and you always store a file in units of 4 kilobytes. That's called a cluster. So if your file is 5 kilobytes long, you use 2 clusters consuming 8 kilobytes because you do not want to address any smaller unit. That's the smallest addressable unit is the allocation unit, which can vary, but it's usually 4 kilobytes. Then every file that is in current use, which means it has not been deleted, so it has a name, a creation date, and other metadata in the master file table, is live data on the disk, and it has an owner and such. When you delete that file, the clusters are not erased, just the information in the master file table is cleared, so it loses its owner, creation date, and file name, but the data is still stored in the clusters on magnetic hard drives. On SSDs, that only happens about half the time because there's garbage collection that deletes it on about half the SSDs. And so those are called active files. Active files are ones that are in use, they have not been deleted, and therefore they have metadata like owner and creation time. Deleted files have lost the metadata, but the contents may still be there, and that's what a forensic tool will reconstruct by just chaining together the clusters. So there are timestamps, a bunch of different timestamps on active file, creation date, last modified date, last used date, and so on. And then there's unallocated space. This is space that's available to store files. Most of it contains previously deleted files, which can be reconstructed, and some of this is file slack. File slack is the little piece. Remember I said if you store a 5 kilobyte file, it will go in 2 4 kilobyte clusters. At the second cluster, you'll only use the first kilobyte, so the last 3 kilobytes of the second cluster may contain fragments of previously saved files that were bigger. You will never get a whole file this way. You'll get a few bytes of a file in the middle or at the end, but you might find something there like a password or a fragment of a Word document or something. And there are partition tables, which are just metadata on the disk to store how you've divided the disk into partitions. So there's various file systems on Windows machines. Everything is NTFS these days. The old systems like Windows 95 used FAT. Microsoft switched to NTFS in 1993. They kept promising various new advanced file systems, and they never made them. So everything is still using NTFS, except there's something called ReFS, which is supposed to be fault tolerant like a RAID on a single platter, but it's not in use, I think, except on some Windows servers. It's not on any client machines of Windows. Then there's UFS inodes that I think are on, I think those are on CDs, and there's HFS is Mac. Mac is HFS and JHFS and JHFS Plus. Those are the Mac operating systems. And as I mentioned, the file allocation table is the really old Windows system that is now only used, I think, on thumb drives. I don't think it's used for anything else. If you had floppies anymore, it would be used on there too. Brian Carrier's book is the authoritative one. I've taught from this book. It's in great detail. When I teach the forensics class from this book, we would actually go in and repair broken files on a disk by fixing bit by bit the construction. And that was pretty exciting, but I decided to quit teaching it at that level because now the forensic tools are very good and you can trust your tool to do that bitwise analysis for you. So then you've got things that come from the application, like your browser. Your browser has a history list, it has cache of files and so on. Your web server and database make logs. your chat client, your email client, and so on. So these things make a lot of logs recording things, and sometimes that data is left behind even when you uninstall the application. Some of those logs and such are left behind. Then you have, of course, the user data, which is what normal users think about, the stuff you would put on your desktop and in your documents folder, your spreadsheets, your emails, your photographs, and so on. And this is probably the most obvious source of useful data if you're trying to find out what users have been doing. And then there's the network services, like I was saying. These are your routers, switches, firewalls, and they have some information typically about where the network has been connecting, what the DNS resolutions are, and things like that, but usually no personal data. They just have addresses to route data from place to place and maybe a measure of how much data went different directions. But your firewall might have logs of suspicious events if people are doing things like running network scans that trigger the firewall, but typically there's no personal data on here, although Glow says sometimes Palo Alto does store personal data on the firewall, which is a strange thing to do, and it'd be interesting to learn more about that. So that's why I used to have a slide here, I cut it out, I thought it was out of date, but during the Trump administration, he made a big deal saying we need to seize the routers. The routers will prove that the voting machines were hacked. And this was, like most things Trump said, this was a strange, bizarre, crazy sounding statement because a router would not have any evidence that you'd been hacked typically. You might argue that a firewall could. Anyway, that was part of, for a long time he claimed that there was an email server in Ukraine somewhere that came from Hillary Clinton and it would prove that everything he said was true and you had to track down this server. And then he said you had to track down the router. He keeps making up a new thing. Anyway, so data can come in a raw form, which might be encrypted or compressed, or might be in some unusual format, like the old Microsoft Office used to have a proprietary binary format for each type of document. You might get the original hard drive. You might get broken files that have been damaged, like old archive copies that are corrupted. That might be the form of your data comes in. So then you ask questions. If you get the data from somebody else, ask good questions. Try to get as much as you can about the history of this evidence, and then you may have trouble using it. A link to the Palo Alto. Let me reopen this up and see what it's saying. This is an intro. Okay, user ID redistribution using Panorama. All right. Let me see if I can figure out what this is. It is Palo Alto Tech Docs. A firewall can enforce policies on usernames instead of IP addresses. Okay. Oh. Wow, it requires a complete identical set of authentication timestamps for your user base. It enforces authentication policy. Whenever users attempt to authenticate, the firewall records the associated timestamps, but don't automatically share it with others. This is something, you're right, I've heard about the modern firewalls are integrated with Active Directory. So they will therefore know who you are anyway. And user information from up to 100 redistribution points. Yes, I'm glad you brought this up. The firewall does know who you are, and I think it even knows like what websites you're allowed. It might probably be keeping a log of what websites you go to and so on. That's a very good point. This layer 7 these modern layer 7 firewalls actually do know a lot of what you've been doing. Very good, thank you. I'll save that link in my news. Palo Alto. All right. Anyway, all right. So you have disk images. This is the if you do take an image of the entire disk, then you can have a logical copy, which is a copy of just certain files, or a forensic image or clone, which is a copy of every bit on the hard drive. And in principle, it could come from a RAID, although usually you don't bother with that. And your disk image is typically stored in one of these three formats: expert witness format, which is by far the most common, the one used by Encase; RAW, DD, which is what Linux makes, which is rare because it's just as big as the original medium. Expert witness is compressed, making it much easier to deal with. And you can also have virtual machine disk files. And expert witness not only is compressed, it's also usually broken up into 2 gigabyte chunks. So you can easily copy it onto a portable device like USB thumb drive and so on. RAW files are hard to handle and not commonly how you do it. All right, but all of them are identical. If you have any of these, expert witness can convert to DD and DD back to expert witness. I'm not quite sure how to convert these back to the other type, but they're all a complete record of the hard drive. So if you have an image of the hard drive, it contains exactly as much information as any other format of the image of a hard drive. It's just a question of how you store it. All right, an FTK imager can convert them, and there are other tools that can convert them. In Linux, you can mount the DD image directly, just as a file system, and then boot from it and upload files to it and download files from it and so on. That's why, as far as Linux is concerned, a disk image is just like a real disk. And then you can have your data encoded. So here's some examples. You can encode something with base64. You can encode it with UU encoding. You can just turn it into a hex. And here they turn it into an MD5 hash, which is not exactly what we normally call encoding because it can't be reversed. But the point is, you might see data in a strange format that is not easily readable, and you have to get used to converting back from the common encoding formats. So here, for example, is a hex dump where you have the address of memory here, then a line of 16 bytes in hex, then 16 characters. And here you have transactions that contain card numbers. Here's a credit card number. And yet, if you were to do a text search for a credit card number saying, I want to find 16 digits in a row, you're not going to find it because part of the number is here and it's broken by the part of the number that's there. So this is the kind of problem you have. There are transformations involved in care in converting this data into a useful form before you can make searches through it. And this is what I used to do all the time when I was working at an escrow agency doing basically forensic work. There were a lot of cases where people would miss important information because of problems like this. And you had to carefully write scripts and stuff to clean up the data to get it in the right format. And this is what happened with Mike Lindell. Mike Lindell had these packet captures that he claimed proved the voting machines had been hacked, and he showed a video from one of his conferences, and I slowed down the video and just typed in the hex values, and all this is publicly accessible records of voters, users, and addresses. These are just ASCII characters. And he claimed these were packet captures that proved they'd been hacked by China, and all it was just a public record of somebody's address. And that's, this is the political theater we're living in, where they throw up something that looks technical, they assume you won't understand it, it's like a Hollywood movie, and then they claim it means something it doesn't mean, and just hope that nobody in the audience knows any better. So then, of course, there's a big problem with localization. First thing, there's the time zone differences on the machines, but even that, if you have a log that contains a time, there's all these different timestamps. There's unique epochs, which is the number of seconds since January 1, 1970. There's month, day, year, and there's day, month, year, and there's all these different things, numbers and characters and everything. You have to convert that stuff back to get it all into one consistent format. So once you process the data to get it in some usable form, then you analyze it. So here's some examples. You're trying to see if somebody's been stealing data from your company. So look for network anomalies, host-based artifacts of data theft, for example. For network anomalies, you can look for a high outbound volume of data. If they stole a lot of data, maybe they sent a lot of data out all on one day, which is a rookie mistake. This, by the way, when China hacked Google in 2010, they did not make this mistake. They put an agent on the Google servers that would take the data and zip it up into small chunks and send it in small chunks slowly back to China. So you didn't see a lot of traffic going there. They detected it, though, because it was going to an address that was not addressed from their company. But anyway, an unusual amount of traffic or an unusual protocol would be a clue. Failed login attempts are a good clue. Another thing you can do is look at the entropy of DNS. Normal DNS looks up things like yahoo.com. Exfiltrating secrets over DNS has like 50 characters of random letters, .company.com, because it's base64 encoding data in the name of the server. And so your server name will suddenly have high entropy. So just monitoring the entropy of the DNS requests will give you a clue if there's data exfiltration going out by DNS. So on the host-based artifact, you can look for abnormal user activity, like running hacking tools, using it at unexpected hours or unexpected durations, connecting remotely in a way that's not normal, high CPU and disk utilization, which is commonly the case when they get a bunch of data and then they zip it to send it away. Look for compression tools like WinRAR and such, and persistence mechanisms like new programs that are going to automatically launch. Those will be the malware that's giving someone remote control of it. And then, of course, there's malware. Your malware that's detected by your endpoint defense systems is helpful. And so you'll typically find a date or something, so look for specific file names. Your indicators of compromise. you can look. One good place to look is everything that automatically starts with something like sysinternals auto runs will find everything that automatically launches, or most everything, and that's the place to start. There are tools that verify the integrity of system binaries. There's a built-in Windows tool to do it, to tell you if any of the operating system files have been modified. And there's other artifacts you can look for, and of course, running an antivirus scan might tell you if they've used known malware on the system. That's a start. The problem is a lot of people don't use malware anymore. They do lol bins. Lol bins are living off the land. Instead of importing malware, you use legitimate tools that are either already present on the system or legitimate tools you can download from Microsoft. And so that's an issue. Then you, of course, antivirus will not find that, and it's more difficult to find. So you can plan your tasks like search for abnormal user login times. Well, see if you have a way to automate that process. You could do it manually, but of course you'd rather have some kind of automatic thing, just trigger an alert. It seems like it would be pretty easy to write a Splunk script to look at the login files and alert you if something unusual like that happens. But consider, how hard is this going to be? How long is it going to take? Who can work on it? And how likely it is to answer your question. This is your job, is to figure out how hard it is to get this data and how likely it is to help you. And then you can choose to expend your resources efficiently instead of wasting your time doing difficult things that don't answer the question. So you can use external resources if there are any, like external things like Dropbox and such. You can manually inspect things, use specialized tools. Sorting and filtering will help you zero in on the important part of data. They call that data minimization, removing all the unimportant data and hopefully preserving the good data. If you don't know what to look for, you can try statistical analysis and just look for data that is abnormal. Keyword searching is the number one tool for typical hard disk analysis. You start with keywords, you search for the keywords, then you find more keywords, you search, and that's how you typically find all the evidence having to do with a crime. And then, of course, file and record carving is what your tools do automatically, reconstructing files from deleted space, which I say it's an interesting process, but it's pretty much automatic these days with modern tools. And so here's some external resources like the National Software Reference Library, and there are others that just have hashes of known files. This saves you a lot of time. You have a whole hard drive image, you can compare it to the library, and you can exclude every file on this list because all these files are standard program files and such, and therefore they don't contain any evidence of attacker activity, and you don't need to investigate them. And the forensic suites like FDK and Encase have this capacity built in to exclude all the obviously boring files, because that's a big step forward. VirusTotal is, of course, the standard to test a suspicious file. It can give you a lot of information, more than ever. You can upload the file, which is a violation of operational security, because if you had a file that was sent to you specifically in a targeted attack, the bad guy will be monitoring VirusTotal to see if it gets scanned, and then they know you caught them. So if you don't want to upload the entire file, what you do is you just calculate the hash and search the hash to see if it's already up there. That does not tell VirusTotal enough to know anything about it, but it lets you know if they already know about it. See, that's searching a hash is a way to find out what VirusTotal knows about this file without letting anybody know that you found the file. So here, for example, let's try this one. I thought this would be interesting. Let's see what it knows. Can VirusTotal, let's keep adding more information. And let's see what VirusTotal does with this one. There's VirusTotal. And I'm going to do a search. And I can put in a hash or URL or a domain. So there's a hash. And so 54 vendors have flagged this file as suspicious. So I have the names many vendors give it. Then I have details here with basic properties, portable executable, 32-bit, creation time from 2014. Here's some names for it. Copyright Microsoft. That doesn't, original name service host, that doesn't seem right. That's the version information. So it's lying, pretending to be a Microsoft product. Text, relocation, and resource sections, importing mscore.dil, which is very strange, the only thing it imports, and only one function from it. Saw hashes of all these sections and objects inside there. It's .NET. Here you have the entropy of various parts of the file to help you look for hidden content. And Here's the kernel used for a few modules. Kernel32.dil and kernel32. That's screwy. Since when is there an external module that is not a DIL? That would be interesting to learn about. And you got relations to certain domains and IPs that have been handing it out. And here's some people with reports of behavior. Here's MITRE attack tools. Nothing much there. Privilege escalation. That spawns a process. Registry run keys. Here's the evasion. Oh, here this is the MITRE analysis. Okay, quite appropriate for us. So here's how it does persistence with the registry run key. It drops PE files to the startup folder. Good. This is actually pretty useful. Here's how it escalates privileges. Here's how it evades defenses. It now does discovery of things on the system. Yeah, so anyway, like I say, VirusTotal gives you an awful lot of useful information. And you don't even have to send anything up there but a hash. So you get all that without having to expose your information. And you can even get in one of the emails of a place this file often is. All right. Then so if you want to do a manual review of things, a small thing, you can just scan the whole thing manually. And manual review is a good skill to have to back up your forensic tools. Forensic tools all have flaws and bugs like everything else. So just because a tool tells you something, that doesn't mean it's true. I've been fooled before. So you always have to verify anything important with a second tool. And the simplest thing is just use a raw hex editor. Then you can make sure that whatever it's telling you is really there. Then there's sorting and filtering. Your metadata might have a lot of files, and so minimization is somehow excluding the irrelevant data and filtering out the important stuff. Filtering by date, file name, and so on is often a good way to thin the pack. And statistical analysis is what you use when you don't know what you're looking for. You just want to see if there's anything strange happening on the network. So you just take some kind of tool, like there's a tool called Sawmill, which I think was in Security Onion, and others. All this does is let you make graphs of things, like page views over time, visitors over time. Here's categories of traffic, spider and such. You just make some kind of graph so you can see some kind of baseline, and then you can see anomalies. Some event happened here, some event happened here. This just gives you something to look at. There's evidence that something weird happened here. A lot of page views. Here I had a lot of visitors. Just graph it in various ways, and that will show you what the exceptions are, and you can look at them to see if they have useful information for you. So strings, this is the process of forensic analysis. You have strings in the case. You have the name of the suspect, an email address, a time range or something. So you search for those, the string, and then you find like emails and instant messages, and you use those to find more keywords and search for them. And that's typically how you build a story of all the available information about certain events on the drive. So we talked about this. The unallocated blocks contains portion of deleted files, and at the end of active files there might be fragments of files, and your modern forensic suites can reconstruct these to some extent so you can view them and get some data from them, but you'll never get timestamps or file names or owners from them, so they're a lot less useful than active data. However, sometimes the most important part in criminal cases, because the bad guy will delete the data, and so the deleted data often is the most incriminating. And this is called file carving. Is this only doable on hard disk drives? No, on about half the SSDs you can do it too. If your SSD does not implement garbage collection, then it preserves data just like a hard disk drive. And that's a function of the operating system, your driver, and the SSD brand and such. The most modern SSDs, most integrated with the most modern operating systems, probably do not have any of that deleted files because they have garbage collection efficiently working, automatically deleting everything a few seconds after you delete it, actually erasing it off the drive. So file carving is this process where you go through random clusters of data and you look for a file header and a file footer. And all modern forensic tools just do the simplest thing. If they find an FFD8, that's the start of a JPEG, and an FFD9 is the end of it. So they just go from the FF8 to the next FFD9, and they call that a JPEG. They assume that there was no fragmentation. That if I find something in cluster 1001, I'll just take cluster 1002, 3, 4, 5, and that's the image. If a file is actually fragmented across several clusters, it will not be correct. It'll show up with only part of the file or with a bunch of extra junk in the middle of the file. But modern forensic tools just ignore that and give you that image. There was an expensive forensic tool that would do a better job reconstructing pictures, and it turned out nobody cared. The actual value of that to an investigation was not enough to justify the price of the tool. All right, and Foremost is one of the simple file. All those forensic suites will do it automatically. The Linux tool Foremost will do it just file carving. It will give it a block of an image, of a disk or anything, and it will automatically extract all kinds of things on it. Look for PDFs, Word files, Excel files, images, and show you what it can find on there. It just has a library of common headers and footers and just reconstructs everything it can find. So you have to evaluate your results. As you go periodically, you stop and say, well, am I getting somewhere, or am I just wasting time analyzing, getting nowhere? And then at the end, you decide, how well have you answered your investigative questions? And typically the questions in instant response are always the same. Where is the bad guy? Are they still in there? What did they get? What did they steal? How did they get in? And how do we stop it from happening again? These are the obvious questions. But you may have other questions in a specific case. All right, let's look at eCahoot.
Can I ask a quick question?
Yeah.
If you did a backup of a Windows machine,
Yeah.
and I can't remember the name of the file when it's in a backup state.
Well, there's a bunch of backups on Windows machines. There's like a hibernation file of the RAM and stuff. But if you do a backup, you get a whole Windows image. But the normal Windows backup does not contain deleted files.
Okay, and so it's I went and did some kind of Windows backup years ago when I was using Windows.
Yeah.
And anyway, that got deleted. And so if I tried to do a recovery, I was wondering what I'm gonna get.
Well, Windows used to have an image file backup back in Windows 7. And that was that's right. So you did a Windows image file backup. You could even deploy that to a new machine. You can just restore it and you have your whole machine, all your data would be there, all your programs and everything. That was the point of it. It was not a forensic image that has every cluster and the deleted files, but it had every active file, which is what you want for normal use. That was the point of it. We used to use that to install Windows. You make a good machine, make a Windows system backup, and then it's restored on many machines. Now you have identical machines. It was a cheap version of Ghost. And so that would be fine. If you have one of those backups, that usually means you can totally restore it on that machine or another machine. And you'll get everything, all your data and all your programs. Yep. For some reason, Microsoft took that away. Around Windows 8, they decided that this was not an important tool, and instead everybody should make a Windows deployment server, because they don't seem to have any sympathy for small business or home users. They just think everybody is a corporation with an IT department to do the complicated thing. So they started hiding that tool more and more. But that was a pretty cool tool. I used to love those image backups. And it may still be in Windows too. They just don't like you using it. They think it's not the best solution. But they're always thinking about corporations and not normal people.
Yeah, I've noticed.
Yeah. They never hesitate to make everything bafflingly complicated. Pretty good creepy music. What's that? Oh, your phone's not working. Oh, that's why I asked you. Give you a little more time. Okay. Well, it shouldn't take too much bandwidth to do this. Okay, whatever. This, all right, anyway. All right. All right. Oh, yeah, good. Okay. All right, so which device typically does not store any user data? Well, the firewall has less user data, although as Joel pointed out, a Palo Alto firewall does have information about your Active Directory account and such, so that's some information about users, a fair statement. Anyway. All right, what's the expert witness format? Yeah, people think it's the Encase format because Encase uses it, but it actually was inherited from a long-dead tool called Expert Witness. Anyway, E01 is the name, is the file extension of the first file. All right, what image format is used for virtual machines? Yep, the VMware disk file, VMDK. Hyper-V uses a different one, and I think the Oracle product, VirtualBox, uses a different format too, but you can convert one to the other. All right, what encoding has uppercase, lowercase, and numbers? That's MD, or base 64, pardon me, not MD5. Base 64 is the one with uppercase, lowercase, and numbers. MD5 is just hexadecimal. I'm not really quite sure what UU is. It's an old Unix encoding. I'm not quite sure what it looks like. There was an example there, but I don't know the pattern of it. All right, and what technique reconstructs images by finding headers and footers? Yeah, that's called file carving. There was a big scary paper about 9 years ago saying this was all going to end because of SSDs, and I gave a talk about it at DEF CON and such, and it turned out it wasn't quite that bad. There certainly are SSDs that delete all the data so you can't do much file carving, but there are ones that don't, so it's still happening even in this world of SSDs to some extent. E40, well, I think they'll have to tell me who they are if they want their thanks. Glowbirds. I think we know who Glow is. And that's a name we know. Oh, good. All right, let me stop the recording.